All right, hey boys and girls, so today we're going to be going over lesson 5, which is exponential versus linear functions. So as I'm reading the do now here, it says, given the two functions below, which would you say is exponential? And we have to explain our answer. So I'm just going to highlight exponential and explain because exponential is a key word, what I'm looking for. And explain tells me I'm not done until I've explained my answer in some way. So if I look at the first equation, anytime I see f of x, I always like to rewrite it as y equals. And I know that we've gone over that with you a few times now, so hopefully we can all be able to just rewrite this as y equals instead. And underneath, I'm just going to write ab to the x. So this is a formula that we had gone over in lesson 2. I'm just going to write that on the side here. This is from lesson 2. And again, it's the formula for an exponential function. And that's what this guy is following right here. If I look at equation B, same thing. Instead of writing g of x, I'm going to change that to y equals. And I'm going to write the formula mx plus b, because that's the equation, or it's the formula for a linear function. And that's what this guy is following here. All right. So I want to answer this question, which one is exponential? I know the answer has to be A, just because this example follows the formula for an exponential function. But if you're unsure, I don't always know the answer. I feel like no one really does. I would definitely just jump onto my calculator and graph both of them. So if I graph the first one, 2 times 3 to the x, it should look something like this. So it should be curved. As I'm moving from left to right and I'm riding that graph, I'm going up and to the right forever. So I'm increasing, I'm going on and on. If I look at equation B and I graph this in my calculator, the 2x plus 3, it should look something like this, like a straight line. And again, it should be increasing from left to right as I go on. All right, so that's how I know for sure by looking at the graph as well that this would be linear and this would be exponential. So now if I want to answer the question, which one is exponential, it would be equation A. And I know it's equation A because that B value, where the 3 is, that B value is telling me, so it represents the number you multiply with. It's going to be the number you multiply by. So I know that those values are being tripled. Since my B value are being tripled, because my B value is 3. All right. So we've gone over a lot of different ways at this point to graph functions and to be able to tell what type of function they are based on their graph. Today we want to really move away from graphing on our calculator and more looking at the actual function itself. And without graphing it, being able to decide if it's going to be linear or exponential. So there's 2 different ways we can do that. We can either memorize what the formulas for linear and exponential are, like these equations I wrote in blue, or you could memorize these tricks that we're about to go over underneath. So if I'm looking at an equation that's linear, I know that the variable x should be raised to the power of 1. So if I look here, x has an exponent even though I can't see it. It's just an imaginary 1, so I'm going to draw that in. If I look at exponential, x isn't in the base, it's in like the top, it's up in the corner. So I know that x here is the exponent itself. All right, so now if I look at example 1, it's asking me to decide which of the functions are linear or exponential. So again, there's 2 different ways that I can do that. I can either look at the formula itself. So if I look at equation A, I can see that it's following mx plus b, which is making it linear. But if I didn't see that right off the bat, or if that was a little challenging for me, because, you know, sometimes the questions are tough. you could use this trick instead. So I can see here that x is being raised to a power of 1, just like in my notes right up top. So again, that's making it linear. I'm going to jump down to c for a minute just to practice it one more time. So instead of writing h of x, I'm going to write y equals. And then again, I can tell that it's following mx plus b. I know there's no b value, so it could be definitely confusing, but really it's like adding a 0 on at the end. So again, because I'm using this formula, I know that it's going to be linear. But if it was hard for you to see that, it's totally okay. Again, I can just check, well, x is being raised to the power of 1. So again, if x is being raised to a power of 1, x is being raised to a power of 1, same thing up top, that makes all of these linear. All right, so there's two different ways you could check to see if it's linear or exponential. If I look at b, a little bit different. I know that y equals a times b to the x. So if I look back, that's the formula for exponential. And since this equation is following that, I know that it's going to be exponential. That's only one method. I could also have said, oh, x is the exponent. So when x is the exponent, that little number up top, I know right off the bat that means it's going to be exponential. And then same thing for d. I can tell right away x is in the exponent, so I know that this is going to be exponential. We just want to make sure that we're always showing you more than one way to solve any question. So I could either check by the formula, I could either check by the exponent. Here x has an exponent of 1. Here x is the actual exponent. Or a third way would be to just graph it. I know we're not doing that in today's lesson, but you absolutely can. If you feel like remembering these tricks or remembering these formulas is a little difficult, definitely just type this into y equal and look at the graph itself. If it's linear, a straight line, I know that's how I could tell. Or if it's curved, it's going on forever, that means it would be exponential. So now I'm just going to jump down to e. I'm going to shortcut this a little bit. So I can see that on e, x is the exponent, so that means it's exponential. X is exponential. If x is the exponent, exponential. Here, f, x isn't the exponent, 1 is my exponent. So again, that means that it would have to be linear. All right, moving on to the next page. All right, so if I look here, this is again just helping me even more decide what's making something linear or exponential. So a few minutes ago, what we just went over was just looking at the function itself and being able to decide if it's linear or exponential. Now we're not looking at the function, we're looking at the actual table instead. So let's start with linear. I know if something is linear if I am using addition or subtraction over and over again. So I'm going to look at the y values to decide if this is linear. So as I look underneath, how do I get from 14 to 10? I would have to subtract 4. And you only use subtraction if it's linear. Same thing, if I had to add 4, I only use addition for linear as well. All right, but I am subtracting 4, so I'm going to do it again. If I subtract 4, well, 10 minus 4 is 6. So right now it's working. I'm going to do it again. If I do 6 minus 4, I get 2. So as you look and you subtract 4 every single time, you're going to see that you get the next y value always. So the fact that I'm using a pattern of subtracting 4, I'm subtracting the same number each time, that tells me that this would have been linear because I'm subtracting the same number over and over. Same thing if I look at exponential. Okay, so exponential only uses multiplication. So I'm just going to highlight that. I have to multiply the same number over and over. And again, I'm going to multiply that towards the y values. So if I look here, how do I get from 4 to 8 using multiplication? Well, 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And if I keep multiplying 2 each time, it's going to give me that next y value. It should always work. So because I'm using multiplication over here, I know that by multiplying 2 every time, that's showing me that it's exponential. All right. I know we aren't really discussing the x values right now, but they are important. I should be using the same number over and over again for the x values as well. So how do I get from -3 to -2? I would have to add 1. How do I get from -2 to -1? I'd have to add 1. So addition and subtraction is only important for the y values. Same thing, multiplication is only important for the y values. But I do want to look at the x's just to make sure I'm getting the same number up top each time as well. So for the x's, this rule doesn't really matter. The only thing that's important is that it's the same number over and over. So since I'm adding 1 each time, that's a good sign. I'm good to go. Same thing over here when I look at these x's. I'm adding 1 each time. And that's a good sign. So again, I would have been good to go. I just want to add that in. But again, the y's are what's important. So now that I've basically finished going over the tables, I just want to take one more minute to just highlight the y values, because again, that's really the goal of those notes, is to look at the y's. So now if I jump down and I look at example 2, it says we want to state whether the tables are linear or exponential. So again, I'm going to look at those y values. So how do I get from 1/2 to 1? All of us, I feel, don't like fractions, and that's okay. I can always come back to it at the end. So let's start with something that's a little bit easier, like the whole numbers. So how do I get from 1 to 2? Well, I could add 1, because 1 plus 1 is 2, but 2 plus 1 is 3, and that didn't work. So since I'm increasing and addition didn't work, now I'm going to try multiplication instead. So I can see that 1 times 2 is 2. I know that 2 times 2 is 4. That's working, that's good. And then the same thing, 4 times 2 is 8. So since I had to multiply 2 each time, I know that this is going to be exponential, but again, it has to work each time. So I still have to check that first value that I skipped. So 1/2 times 2 is 1. All right, so since it's working all the way through, I know that this would have been exponential. Now I'm going to look at B. Same thing, I want to look at those y values. So again, anytime I see f of x, I know that's y. Now I'm seeing t of x, that's y. So I'm just going to fill that in. So how do I get from 10 to 7.5? Well, now my numbers are getting smaller, so I should be either thinking subtraction or, again, maybe multiplication. Let's try subtraction. So if I take 10 and I subtract 2.5, I get 7.5. So right now, it looks like I'm going to try with subtraction. Let me keep going. If I do 7.5 minus 2.5, I do get 5. And if I subtract 2.5 all the way through, I do get 0 at the end. So since I'm subtracting the same number all the way through, I know that this would have been linear. All right, again, this is exponential because I used multiplication. And I know this is linear because I used subtraction. All right, at this point, you guys should try to pause the video and try maybe C, D, and E on your own, and then come back and check it when you're done. I'm just going to keep kind of working here, and then, like I said, just check back in. So now if I look at C, same thing. If I add 7 each time, it's working, so I know this has to be linear because I used addition. If I look at D, I'm going to multiply 3 each time. And if starting with the fractions is too tough, that's totally okay. Start with the whole numbers. So 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So right now it looks like that's working. I just have to check it for the fractions up top, and you would see that it does. It works all the way through. So this would be exponential because I used multiplication. And then last but not least on E, if I were to try to add 2 each time, it works out. So because I'm adding the same number each time, it's linear. Again, because I used addition. All right. So moving on to the final page. So if I look here, now I'm still looking at what's making these word problems now that we're looking at, linear or exponential, based on the vocab. So on the first page, we decided if it was linear or exponential by the function. The second page, we decided by the graph, by the actual table, I should say, the table itself. And now I'm going to decide by looking at the word problems. So as I look here, I'm just going to take a minute to remind myself that if I see linear, something that's linear, I know that I'm looking for addition or something with subtraction. These are other key words that you definitely want to keep an eye out for, but addition and subtraction is probably the most important. Same thing with exponential. I know I definitely want to keep an eye out for multiplication, but a dead giveaway, if I'm using an exponential function, you would always see a number that has a percent tied to it. That would make it exponential. All right, so just keep that in mind. It's almost like a little trick. So as I read these word problems down below, I have to decide based on the vocabulary, whether it's linear or exponential. So again, that's the goal. I have to decide which one it's going to be. So if I look at part A, it says a sunflower grows at a rate of 3.5 centimeters per day. So I'm just going to highlight what's important here. So I know that grows is a nice vocab word. If something is growing, I know that it's increasing. So I'm just going to write that in increasing. And I can see that the rate is 3.5 centimeters per day. So that means every day it's increasing 3.5. So on day 1, it was 3.5 centimeters. On day 2, it grew another 3.5. Day 3, it grew another 3.5. So because I'm increasing 3.5 each time, it's making it linear. Part B, the value of a car depreciates, so that's a really important vocab word, at a rate of 15% per year after it was purchased. So if something is depreciating, that means that it's losing value. And usually when something depreciates, it depreciates at a percent. That's why this number has a percent attached to it. So if I look back up top at my vocab words, I know that any number that has a percent attached means it's going to be exponential. So I know that part B would represent an exponential function. Just like part A, I know that anything that's growing, it's increasing, it's adding, that would have made it linear like it did for part A. All right, so that's basically what you want to do here. You have to look for those key vocab words to decide what's happening. I'm going to keep just going with the video, but if you want to pause it and try these next few on your own and then watch me go through it when I'm done, I feel like that's a really good idea to do as well. All right, so I'm going to continue. Part C. The amount of bacteria is tripling every 2 days during an experiment. So I know that if something is tripling, that means that I'm multiplying by 3 each time. This was actually from the do now as well. So anytime I'm using multiplication right away, that makes it exponential. So I'm going to fill that in. But you could always create a little table on the side for yourself. After 2 days, it was 3. After 4 days, it was now 9, because 3 times 3 is 9, because it's tripling. All right. If I look at D, it says a farmer plants 2 beds of flowers every day. So I know if this is happening every day, he's adding 2. So that means on day 1, let's write that out. On day 1, he had 2 beds. But he's doing this every day. Every day he's planting 2 beds. So on day 2, he planted 2 more, which makes 4. On day 3, he planted 2 more, which makes 6. So since I have to add on another 2 beds, that's making this linear because I'm using addition. If I look at E, it says a bank account is growing. So when I hear growing, I think increasing. But I'm not increasing by just a number. I'm increasing by a number with a percent. So anytime I have a percent, I know that means it's exponential. Part F, it says the cost of a gym charges an initial fee. So that's like your starting fee. Plus $40 per month. So I know that every month I'm going to add on another $40. So the fact that I can see here that I'm already using addition is telling me that this would be linear. But again, I'm adding 40 after the first month. I'm going to add on another 40 in the second month. Add another 40 in the third month, right? So on and so forth. So again, that's why it's linear. If I look at G, it says the concentration of medicine in a person's body decays by a factor of 1/3 every hour. All right. This is going to be exponential. I'm kind of like running out of room here, so I'm going to shorthand it, exponential. Because if I look back at my vocab words up top, if something is decaying, let me just highlight that. If it decays, I know that that means it's exponential. So if it's decaying by 1/3, I'm going to even give you an example. So if I had, let's say, the number 9, and it was decaying 1/3, decaying means to go down. It means like to decrease. So if I'm decreasing 1/3 every hour, that means I want to multiply by 1/3. So if I have 1/3 of 9, that's really going to be the number 3. So I started with 9, now I'm at 3. In the next hour, it's going to decay another 1/3. So 1/3 of 3 is 1. So now in the third hour, I'm at 1. I can see that not only are my numbers decreasing, but they're decreasing at a rate of 1/3. So I can't use subtraction here because it won't be the same number each time. It's multiplication. So that's exponential. If I look at H, a number of players left in a tennis tournament decreases. So decreases is like to subtract. It's decreasing 1/2 each round. All right, so let's say that the number of players that we started with was 20. I know that those players are going to decrease, so they're going to go down by 1/2 each round. Well, what's half of 20? 10. So I started out with 20 players, but after the first round, I was left with 10. What's half of 10? 5. So after the next round, I lost 5 players. I lost half of them. So I know again that I'm really multiplying by 1/2 each time. And anytime you use multiplication, I know that represents an exponential function. All right. And then if I look at I underneath, it says a student is saving. Saves is a key word. I want to accumulate money. It's an increase. saving $300 every month in a savings account. So again, I know this has to be linear because I want to add $300 every month into my account. So in the first month, I have $300. In the second month, I want to add $300 to it, which now gives me $600. Again, the next month, I should have $900 because I want to add another $300. So I'm saving $300 every month. That means I'm adding $300 every month. That's what's making it linear. All right, don't forget to try the homework and the closure on your own. Take time, pause, rewatch if you have to, and just do your best. You guys are killing it. Okay, have a great day.